been a while since I published the videos for the last element of the agent-based modeling module. As it turned out, as you'll see shortly, there were far more things that I needed to learn than I realized. So it's taken a while to sort of get my head around certain aspects of this whole agent-based modeling stuff. So in this particular element of the module, I'm going to talk about this deceptively simple agent-based model, which defines an agent which can be in a state pop A, pop B, or pop C, which are intended to be sort of akin to the agent being part of a population. And the agents can move based upon some transition equations that we'll talk about later. They can move based upon, and how they move is dependent upon which population they're part of, and they can reproduce and they can die. Now, initially, the intent is to populate the population with just three agents, and to populate them in such a way that they're distributed on a grid that's 50 by 50. And the way that it distributes them is using this crazy center self-index, this center function, which is actually a function defined as a macro. Macros are a capability within Insight Maker to define functions that you want to use over and over again. So it defines the first population, population A, to be at a location 1010, population 2 at 4010, and population 3 at 2540. The way that lays out on the grid, and I'll show you in just a moment, we're initially going to run this model from time in hours from 0 to 0, which means it will simply initialize and not do anything else. So it populates this 50 by 50 grid, and it puts agent 1 here based upon this formula, this function, so that agent 1 is at 1010, which is here, and the second agent is at 4010, which is here, and the third agent is at 2540, which is up here. So that's what this custom function does using that macro, is to go ahead and place these agents in these locations on the grid. Now, the idea is that these agents, well, before I talk about that, the one part of this that I didn't quite understand was that if I run this from 1 to 10, every time increment, it will cycle through each one of the agents and determine if there's supposed to be a transition or an action. So it would run for 10 cycles and run through 3 agents each time, but it has nothing to do with the time step, so that if I change the time step to 0.25 or 0.025, it would have no effect on the model whatsoever. The simulation time step only comes into play if you're doing a hybrid model and some aspects of the model have system dynamics elements in it, such as stocks and flows and variables, so that part of the agent-based part of the simulation is only based upon the stepping through the time steps, or not time steps, the time units, the number of them, and the simulation time step is only plays into the mix if you have a hybrid model. So the way that this is set up is there's a 5% probability that an agent will transition from pop A to pop B, a 10% probability that the agent will transition from pop B to pop C, and a 15% probability that they will transition from pop C to pop A. Now, what happens is that if I go ahead and do this, the thing is that the pop A agents are supposed to be in this location, and the pop B ones in this location, and pop C in this location. So the move function is set up in such a way that if it attempts to move agents toward where they're supposed to be, so that it attempts to move the agent 2 units toward where it's supposed to be, but it also adds a random movement between -1 and +1 around that center point. So if I change this and run it for 10 time units, what will happen is you will notice that some of these elements or some of the agents will change, and then they will begin to move in a direction. It's probably easier to see if I run it for longer. So while the pop A agents are supposed to be here, and the pop B's are supposed to be here, and the pop C's are supposed to be here, notice that this is an agent that has transitioned to pop B and it's moving in this direction. This one is a pop A agent which was somewhere up in here and is moving in this direction. And this is a pop C agent which is moving toward the location. So what the simulation to this point does is provides an indication of how you can actually create a set of agents, at this point just 3 of them, and locate them on a grid and move them based upon the state that they're in, and have them be able to transition between states. Now there's a couple additional aspects to this in terms of being able to reproduce and die, and I'll take that up in the next video. So see you shortly.